Okay, so far we've done graphs and tables to find the solution to quadratic equations or to find zeros. We've done factoring to find zeros. And we did completing the square. Okay, so we just looked at that again. And then the last way to be able to find zeros with quadratic equations is called the quadratic formula. And the quadratic formula was actually developed using completing the square. So we've looked at, here's our standard form for a quadratic equation. Ax squared plus bx plus c equals 0. Okay? And it's, for most of the things we work with factoring, graphs, and tables, we always want it to be equal to 0. When we did completing the square, we don't want it to be equal to 0. We want to just have all the variables on one side, the constants on the other. But when we do the quadratic formula, we're going to have it equal to 0 also. But when they took completing the square and they left the variables in it, they developed this thing called the quadratic formula. Now, and I think it might be, is it over there somewhere? No, I guess it's not. Okay. When I write this, so you're going to want to make sure you have this written down. All right. When I write it, I actually write it as two separate pieces like they do right here. And the way I do it, I'm always going to write it that way as two separate parts. The reason is, look at the first part, the negative b over 2a. We've used that a couple different times, haven't we? What's negative b over 2a help us find? What things? Okay, the vertex. It gives us the x coordinate for the vertex. Okay, what else is that? Okay, it's the axis of symmetry. So what happens is, because this is negative b over 2a, if you look at this, here's the axis of symmetry, right here. Cuts the graph in half, and then the plus or minus part, okay, means that from that number, from that x value, we're going to add a certain number and subtract a certain number to find my zeros then. Okay? So the quadratic formula uses things that we've already looked at to help us find zeros. And so like I said, this is the way I'm always going to write it. Negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. I'm always going to write it that way. All right? In your book, they'll always write it this way. Okay? And it's basically a preference. Okay? One reason why I like to do it with them pulled apart is sometimes simplifying it is easier that way too. So here they give us a quadratic function, and they want us to find the zeros. So to find the zeros, we're going to do the quadratic formula. And the first thing we're always going to do to use the quadratic formula is identify the values of a, b, and c. So for this problem, what's a? Okay. A is just the coefficient of x squared. So a is 2. You're never going to put any, most of you will never put anything in for a, b, and c except for a number. Okay, you get the pre-calculus, there's a thing we do in there where we end up having to do something different, but if you don't go there, you won't have to worry about it. Right now, you don't have to worry about it. What's the value of b then? Negative 16. It's the number in front of the x. And c is 27, the number by itself. And then once you identify them, all you have to do is plug them into the formula and simplify it. So this is just another way of solving a quadratic function, finding the zeros or solving an equation when it's equal to 0. You can do this for any of them and it works. Even if it's factorable, you could do this and it would work. So x equals negative b. So the opposite of negative 16 over 2 times 2. We've done this a bunch of times already. Finding the axis of symmetry, we did that part right there. We're just adding in this other part, plus or minus the square root of b squared. Make sure you put this in parentheses if it's a negative, otherwise you will make a mistake. Minus 4 times a times c. And then it's divided by 2 times. Now notice, okay, now there's a reason why they like to write it this way also. One reason is it shows you that the 2a is completely in the denominator. Right? So notice when I wrote this, put this fraction bar here, I made sure that it extends the whole thing, which means that you have to do the square root before you divide by 4. Okay? The 4 is not under the square root. It's outside of it. So we get 16 divided by 4 is 4. Then we just need to simplify what's in the square root, Spencer.
So the first b instead of negative b, they always have to be negative?
There's always a minus sign here. Yep. Because it's a negative b, the opposite of whatever b is. Okay, so if b is a negative number, it's going to end up being positive when you put them together. Okay. So what do I get when we square, or what's underneath the square root sign? What's 16 squared minus 4 times 2 times 27? $40? Okay. And that's divided by 4. Hmm?
Oh, no.
Okay. Nope. Negative 16 squared minus 4 times 2 times 27. Positive 40. Now we have to use our skills with radicals. So let's pull that over here. Square root of 40. What does that equal? It would equal 6.34 if I did the square root of 40, but I have to simplify the radical. Okay? One of the things we've done a few times in this class. So this is the square root of 4 times the square root of 10. All right, remember we're finding the largest square then. Square root of 4 is 2. So this is 4 plus or minus 2 square roots of 10 over 4. Yes, Spencer. Mm-hmm.
That negative b in the first one, is it always just going to be like the opposite number?
Whatever b is, it's going to be the opposite. Yep. So this would be 16 divided by 4. So this equals 4 plus or minus the square root of 10 over 2. All right, and we're going to write our answer that way. We're not going to write it as a decimal. Okay. We're going to leave it like that. Okay. Now, could I check that answer? It's not easy to check, is it? But I could. All right. We could even check it by going to your online calculator we were looking at the other day. All right, so let's try it and see. So what do we have here? 2x squared minus 16x plus 27. And graph it. Okay. Now, notice, our negative b over 2a was 4, right? Okay, that's the axis of symmetry. So if I hit trace, put in 4, there's our vertex, right? Okay, the axis of symmetry. So if I can trace and do 4 plus the square root of 10, close the parenthesis, divided by 2. Okay. What am I looking for? To see if it equals 0. Okay? Or something really close to 0. Right? And here it equals 0. It's approximately 5.58. And I could do it the other way. 4 minus the square root of 10 divided by 2. All right? That equals 0. Okay? So I did it correctly by checking it. So to find the zeros for a quadratic function, if you can't factor it, okay, this is really the easiest way to do it then, to get an exact answer. Identify the values of A, B, and C, and then plug the numbers in and simplify it. Okay, so we identify A, B, and C again. So A is 4, B is 3, and C is 2. Now, the only difference with this one is you should end up with a negative number on the radical, right? So then we're using our imaginary or complex number part then. So x equals negative 3 over 2 times 4, plus or minus the square root of 3 squared minus 4 times a, which is 4, times c, which is 2, over 2 times 4. So we get x equals negative 3/8 plus or minus, and here we're going to get 9 minus 32, right? Okay, what's 9 minus 32? Okay, all right, so we get the square root of negative 23 over 8. Okay. Now, is that the answer? Okay, no, it's almost the answer. The only thing I need to do is pull out the negative. Okay. So this would be negative 3/8 plus or minus the square root of 23 over 8. Now, you have the option with the I. The I can either go in front, or whenever there's a fraction, you could put it right in the middle of the fraction if you want for your answer too. So it can either go, like I said, it can go in the front if you want, or where there's a fraction, then you could put it in the middle of the fraction bar. And that would be okay, because then it doesn't look like it's under the radical either. You cannot solve for I. Okay. Part of the quadratic formula, the part underneath the radical, has its own name to it. It's called the discriminant. And we can use that part, b squared minus 4ac, to tell whether there's going to be 2 real solutions if it's greater than 0, which we found out in example 1, 1 real solution, or there could be 2 non-real complex like we found out in example 2. Because if it doesn't cross the x-axis, we have 2 answers that would have I in it, because we have the plus or minus tells us we have 2 answers, the plus the number and minus the number. If it equals 0, that means then that there's only one answer, it hits the x-axis, because then if it equals 0, the vertex is right on the x-axis then, okay? Like they have in this case here. And if it crosses the x-axis, comes back up, then you have 2 solutions like in this case here. Now to find these, first thing is it's got to be written in the correct order. Okay, Spencer asked earlier, said, are they ever going to put it in different order? And yes, sometimes they will in this situation. So when we have a quadratic function, unless you're going to complete the square, it's always got to be in the form ax squared plus bx plus c equals 0. So in this example, they want us to find the type and number of solutions for each equation. So when they're asking for type and number, this is it, 2 distinct real solutions, or 1 distinct real solution, or 2 distinct complex solutions. So the first thing we have to do is get it equal to 0. So we're going to move the 12x to the other side. And then we're just going to do the b squared minus 4ac part of it. The part that's under the square root. Nope. We just want to know whether this is positive, negative, or 0. So all I have to do is just, once I write that down, just type it in my calculator and see what you get. In this case, we get 144 minus 144, which is 0. So that means then, since it equals 0, we have since it equals 0, that means then we have 1 distinct real solution. And in this case, this is going to be factored. X minus 6 times x minus 6, so there is only 1 0 there. Letter B. Move the 12x over again. And do b squared minus 4ac again. So that'll equal negative 16. And since it's negative, what, man?
I'm just looking back, you're smiling. You're just giving me some dirty looks.
I wonder why. All right. So if it's less than 0, then, if it's negative, then we have, oops, 2 distinct non-real. Right. Yeah. Okay. All right. So you do letter C.